All right, welcome. So we're talking about electron transfers, which is basic oxidation and reduction. So we should also remember that oxidation means the loss of electrons. Loss of electrons is oxidation, and reduction means the gain of electrons. So the reason why the gain of electrons is reduction is because charge goes down when you gain electrons, because it's negatively charged. And when you lose electrons, your charge goes up. So reduction of charge means you're gaining of electrons. All right, so number one, which half reaction shows conservation of charge? That means the charge is the same on both sides. So in part A, copper with no charge is a 0 and a negative electron. So this whole side is -1, and the right side is +1, so that can't be it. In part B, we have a +2 and we have a -2, which means this whole side is 0. And this copper over here with nothing means copper 0. So that should be our answer. Let's keep going. Copper +1 on this side. This is a 0 minus, so this is -1, this is +1, so that's not it. And in part D, we have +2 here, and we have 0, -2, so this side is -2, so that's not it. So B for number 1. Which expression correctly represents a balanced reduction? So the gain of electrons is reduction. When you're gaining electrons, your charge goes down. So also gaining electrons, you see that as a reactant. So electrons are on the left side generally. Okay, so in part A, I think that's our answer because we are at +1. We gained an electron over here, and then we have an A0, so our charge is going down. So that should be our answer. But in part C, I also see electrons here. So gain of electrons is reduction. So, but it's also balanced. That's the key. So you can see that in part B, we have gone up in charge, so that's not our answer. And in charge D, our charge goes up too, because this is a 0 and this is a -1 here. But the reason why it's not choice C is balanced, not only for charge, but you also have to balance for mass. Meaning, I have 2 chlorines here, I only have 1 chlorine here. So that's not balanced in terms of mass. In part A, 1 sodium, that's our answer. A chemical reaction, I just talked about this. A chemical reaction always demonstrates the conservation of nothing, matter. So conservation of matter, which can be mass, charge, energy. It's definitely not going to have conservation of temperature or volume. What half reaction is correct for the reduction of Al +3 to Al0? So what we're doing is we're saying, okay, Al +3 to Al0. So reduction means gain of electrons. So in part A, I have Al +3 gaining 3 electrons to Al0. That's my answer. Al +3 plus 3 electrons is not all of a sudden going to get us 3 aluminum. So that is not, mass is not balanced here. In part C, we have a +3 on this side, and we have a -3 on this side, so charge is not balanced here. And in part D, we have +3 on this side, and we have actually mass and charge are both not good for D. Number 5, which half reaction shows both the conservation of mass and conservation of charge? So again, we want the same number of atoms on both sides. So in part A, 2 chlorines on both sides, that's good. And then this side is -2 overall, 0 and a -2. Oh, and this is -2, so that should be our answer. In part B, we have no mass conserved because 2 chlorines here, 1 chlorine here. In part C, we have 2 bromine, so this is -2 here, plus another -2, so that would be -4. And then we have just a 0 on this side because there's no charge. So mass is good, but not charge. And finally, charge, this is a -1, this is a -2, and also 1 bromine, 2 bromine, so that's wrong. So 5 is A also. Number 6, which equation shows an oxidation? So oxidation means loss of electrons. So when we lose electrons, electrons are going to be on the right side. Think about them being given off. And that means charge is going to increase. So we have bromine Br2, charge of 0, going to -2. And this is, so, oh, this is -4 overall. That's not doing it. Okay, so in part B, we have Br0, 2 of them. Okay, mass is good, 2 bromines, 2 bromines. But this is a -2, and this is a -2. That's good. Yeah, but unfortunately, that's not a loss of electrons. This is a gain of electrons. So that's called reduction. That was balanced, but it's a reduction. In part C, manganese is balanced for mass 1 and 1 atom, but this is +2 -2. So that would be 0, and this would be 0. So, I mean, that's balanced, but again, that's a gain of electrons. That's reduction. Our charge is going down. So in part D, this should probably be our answer. Mn is a 0, and now we are at a +2. We've lost electrons. There they are. And now my charge has gone up. That is my answer. That is oxidation, part D. Which is a reduction half reaction. So again, a gain of electrons is reduction. That means electrons are on the left. That means our charge is going down. So in part A, Na0 becomes Na+. That looks like a loss of electrons there. Na0, oh, this is a gain of electrons. So this is going to be a -1. Oh, but it's not Na0. Yeah, this is going to be an overall -1, and this is going to be overall +1. That doesn't balance. That's not what we want. Part C, Na +1, and then this is going to be 0, so this would be -1. That doesn't work. And then we have +1, -1, so that's going to be 0. This one is also 0, so D. Which half reaction represents the oxidation. Loss of electrons is oxidation. When you lose electrons, your charge goes up. When you lose electrons, electrons are on the right. So again, we've got Li+, and it's okay, so this is going to be a 0. This is a 0. That looks good, but our charge went down. That's not what we want. This would be a reduction. We have a 0, so this is going to be -1. This is going to be a +1, so that doesn't balance, so that's wrong. Li0 to Li0, so this is -1, so that doesn't balance. Li0, +1, -1. Okay, so that balances. So is this the loss of electrons? It is, because charge went up. So 8 is D. Which is reduction. Gain of electrons is reduction. So gaining electrons. So 0 here. No, this is a loss in A. So our charge is going up. In B, this looks like a gain of electrons. 2E- to a 0. Yeah, this is a B. Just to keep going, 0. So this would be -1. This is a +1. That's not balanced. +1, and then this would be -1. So that's not it either. So 9 is B, and 8, I didn't write these on the lines. Sorry. Given the balanced ionic equation, where are electrons transferred? Okay, so remember, if there's no charge written, it's a 0. So we say, okay, so who is, we need to see who is losing, who is gaining. So who is losing electrons? And when you lose electrons, your charge goes up. +3 to a 0. And that's not going up. That's going down. Mg. Yeah, so Mg is oxidized. And so then we have reduction. Must be the aluminum. Al +3 goes to Al0. And Mg0 goes to Mg +2. So then we say, all right, where are the electrons going? Well, they must be going from Mg0 to Al +3. So that should be choice C. Oxidation, loss of electrons is oxidation. When you lose electrons, electrons are on the right. And when you lose electrons, your charge goes up. So again, this is a 0, and this is a 0. So if you go from a 0 to a +2, charge goes up. So it has to be zinc. So we say, okay, So zinc 0 becomes Zn plus 2 aqueous. So solid is on the left, aqueous is on the right. Let's make sure this makes sense. So, wait. Ooh, what? So where did the electrons go? Is it either A or B? So if we're losing electrons, electrons are on the right, which means it has to be B, which it is. So yeah, then we have a 0 becoming a plus 2, and then 2 electrons are being given off. Finally, when a lithium atom, that's B. When a lithium atom forms an Li plus ion, the lithium atom, okay, so first of all, we're not gaining protons or losing protons. They stay the same. But when we're being positive, cation means we've lost electrons, become more positive. 12 is D. All right, if you have any questions, please reach out. Thank you.